No one can claim that at any point in time that we will reach a state in which we don't have no longer any improvement opportunity or any issue with our production or our operations. Therefore, one can claim that improvement opportunities are infinite, and the problems or issues also can be infinite. And also, for these issues or problems, the potential causes for them can be too many to tackle all of them. So we need to figure out a way in order to prioritize the issues or the improvement opportunities uh, or potential causes in a way that is quantifiable, that allows us to identify the vital few opportunities or issues or causes, and focus on them rather than wasting our efforts on trivial many issues or causes or problems. And here the Pareto diagrams can be very helpful. So in Pareto diagram, um, we want to make use of our data that we already know in order to prioritize our efforts, in order to take the necessary actions in areas that's more significant than the others. So, for example, we have this table of um, number of inspected items, and here we have the number of defectives and the percentage of defects, and also the distribution for each defect. How to visualize this, how to see this in a visual way, so that we know um, if I want to, for example, target 80% of the issues, which items should I pick and select. So let's see. So we have here this Pareto diagram, and we can see here that we have the left axis representing the number of defectives, and also we can see here the different issues for these defective items, and we can see here the kind of a histogram, and also at the same time we can see this line graph. So the right axis also represent the percentage of distribution, and also the horizontal axis represents, as we said, the defective items, starting with the most frequent ones. So experience has shown us that it is easier to reduce the toolbar by half than to reduce a short bar to zero. So as you try to reduce the amount of issues in a specific categories, as you go near to zero, the more effort that you need, right? We know this. So for example, if we have an 80% good items and 20% bad items, to reduce those 20% bad items to 10%, you can identify the key issues and then reduce, right? But as you approach the zero, as you go below 10%, you will have many issues that are very scattered in different areas. So your effort will be harder and harder to reduce to zero. So it's always advisable to start with the biggest issues, and then later on you can tackle the less vital issues. So here we have the Pareto diagram, and it helps us, as we spoke, defining the priority for improvement, and also it helps to having this common understanding of priorities, so that
when you discuss any issues with your team or with the specific stakeholders, you can have an objective way of identifying the priorities for improvement. Also, it can help us identify the weight of each cause, and also it can help us with tracking results. So after you tackle the caulking, it should move to be the second or third priority after your improvement is done. Here you can see, for example, if I'm to tackle 75% of the issues, I will go build the horizontal line and until I touch this line graph, and then I go down. Anything to the left are areas for focus to tackle 75% of the issues, and the same I can pick any percentage and do the same until I solve the problem. Once you identified those issues and solved them, you need to redraw the Pareto diagram and see where you stand. Are the caulking stands still as the biggest issues? In this case, you need to focus on it again. Otherwise, you need to pick the first issues accordingly. Here we have some examples. So to the left here we have the Pareto diagram of the hours spent by warehouse workers on different jobs. So I have here receival, dispatching, and whatever. And if I'm to focus my effort in reducing specific type of work to improve the productivity of these workers, I should first work on the receival, then dispatching, and then the other stuff. If I'm to identify the specific percentage that I would like to reduce in these hours, I need to complete my histogram and draw the horizontal line with the percentage, and then pick the percentage that I wish, and then identify the key issues, and then tackle them accordingly. Also, I have here this breakdown of machine issues. So here we have oil pressure, hydraulic clutch, and other factors contributing to the stoppage of the machine. And if I'm to focus on the highest issues so that I reduce the downtime of our machine, I need to focus first on oil pressure and then the hydraulic clutch. And again, if I'm to identify the percentage of if I'm to identify the percentage that every task with every issue will contribute to, I can draw also the vertical line with the percentage and the line chart so that I can identify exactly if I'm to reduce, for example, the downtime by 50%, which causes should I focus on. Here, there is an interesting way of using the Pareto diagram. So, for example, here I have specific injuries by type, or sorry, by body part. Here we have the fingers, eyes, arms, and legs. Currently, I have the highest frequency with fingers. I can deep dive inside finger issues by drawing a Pareto diagram only for fingers, and here we can identify the causes. So here this is the first cause, second cause, and this is the third cause, and I should be focusing on the first cause first because it is the one that is more contributing to my issues. So here I identified the areas of improvement, and then here I used the Pareto diagram in order to identify the key issues for the specific area of improvement that I'm focusing on right now. Here we can see a case in which we can monitor and track the performance before improvement and after improvement. So on the basis of before improvement diagram on the left, the problem of defectives due to improper rotation was selected for improvement. The items for inspection in the measure process were determined to eliminate the possible factors causing improper rotation. And then the workers engaged in these tasks were asked to check the results of their work. In this way, the diagram on the right was obtained. Comparing the before and after improvement graphs, it can be seen that improper rotation is no longer the first issue, and it dropped to be the second most important source of trouble. The first place is now being taken by the previous second source, which was noise. In this case, we can later on focus on noise, and we can know from this exercise that our improvement effort was successful in reducing the improper rotation issue. So how to develop a Pareto diagram? So your first step should be to identify what you're trying to prioritize. So identify the classification. For example, am I monitoring the defects or work groups or products, different sizes, different damages, and so on and so forth. So by doing so, you can later on use these classifications on your horizontal axis. Identify a time range in which you will collect the data for each of those classifications, and sum up each classification for each um, uh, and, uh, and calculate the percentage, and then draw the bar chart from the highest to the lowest total per classification. Then draw the line chart over the bar chart using the secondary vertical axis by cumulative percentage. So the vertical axis, we have two vertical axes. The left one, I can use it for showing the frequency of each classification, and the right hand side axis, I can use it to represent the cumulative percentage for those classifications. Then finally use the percentage axis in order to identify your target classifications. So as we saw before, in order to target 75% of the issues, I should be focusing on connecting and caulking issues.